Avogadro's law.
This call is now being recorded.
Avogadro's law, we have Boyle's law, we have Charles' law, we have combined gas law, we have ideal gas law, and the last law we have Dalton. So madam give you a shortcut to remember how many laws we have got for the gas. Okay, ABC square ID. Okay, we got Avogadro's, we got Boyle's, we got Charles. The square stand for, you have another one is the C stand for combined. Then we have ideal gas law. And then last one, we have our Dalton's law. Okay, so let's just go into the Dalton's law. So in our Dalton's law, it says here, in a mixtures of unreacting gas. So please highlight unreacting gas. So that means the gas inside your mixture must be no reactions one. Okay, so the total pressure will be the sum of the partial pressure of the individual gases at a constant volume and temperature. Okay, so the partial pressures over here means that it's the pressure that exerted by individual gas inside the mixture. In another words, it's a individual pressure for each of the gas contained inside the mixture. Okay, so that refers to Dalton's law. And it depends on how many gases we have inside the mixture. So if let's say inside a container you're containing 3 gases, then the total pressure will be total up the individual pressure of these 3 gases. If you got 4, then you just add it up 4. Got 5, then add it up 4, 5 together. Okay, so in general, your Dalton's law can be represented by this formula. Okay, P total equals to PA, stand for partial pressure for gas A, PB, partial pressure gas B, PC, and let's say if you got more than that, then you just add it more. PD, PE, PF, and etc. Okay, but over here, the ABC just stand for the unknown. Of course, you will know what is the gas. Maybe it's oxygen, then you will be, let's say lah, okay, Madam bagi contoh kalau sekarang ada oxygen gas, so you will need to have PO2. So the total pressure, let's say I have oxygen gas, I have argon gas. So this is how am I going to write? Okay, according to the formula of your gas. ABC in this case is just an unknown. Do you get it? Is it okay?
Yes.
All right. So, for example, in the diagram, I'll show you some colorful pictures. Gas A, the red color. Gas B, and then we got a PB. Gas C, we got PC. So the overall total pressure, we just adding up together. So that means in this container, we're containing gas A, gas B, gas C. But they are all unreacted. A tak boleh react dengan B, B tak boleh react dengan C. Tak ada reaction langsung. Baru awak boleh applykan Dalton's law. Okay. Kalau ada reaction, macam sebelum ni yang awak guna. Macam tadi, CuO campur dengan H2. So that one apply ideal gas law, apply Boyle's law, about Charles' law, okay, no problem. Dalton's law is for unreacting gases only. Okay, so we have 2 methods to find each of the partial pressure. All right, so the first method's over here. Each of the gas behave independently, so the ideal gas law expressions for each gas. So if you want to find the partial pressure for A, then we will apply the PVNRT, but we just try to rearrange to make pressure the subject. So nRT over V. But in this case, if you look at the individual formula, you will see why there is an abbreviation A and A. Abbreviation B and B. That means awak ada lebih daripada satu gas. So untuk simbol tu mesti kena ada. Tak boleh semua sama kan. Nak cari oksigen pun nRT over V. Nak cari argon pun nRT over V. Tak dapat nak bezakan. So you must put the abbreviation. Okay, abbreviation maksudnya huruf dekat sini lah yang Meda highlight kan. Okay, so we follow the example just now, partial pressure A and ART over V. So that means the temperature and the volume is fixed. Container yang sama, so volume yang sama. Container yang sama, system sama, temperature pun sama. So we have PA, PB, PC. That is the first method. Okay, So again, repeat again lah. The Dalton's law, P total equals to PA plus PB plus PC. The second method is over here. You want to find the partial pressure from mole ratio also can. So, Madam want to ask, mole fraction awak pernah belajar dalam chapter mana? Anyone want to let me know?
Chapter 1.
Chapter 1. So, you still remember mole fraction sebelum ni awak guna formula apa? So, let's say saya nak cari mole fraction untuk A.
NA over NA plus
Ya, NA plus NB ataupun N total kan. Kalau ada tiga kelas pula. Ada tiga gas, so dia akan cari total dia. Oh, this is what you have previously learned in your chapter 1. So in chapter 5, we revise again mole fraction, but this time we use the partial pressure. We use the total pressure instead of number of mole. Okay, so kita boleh pakai macam ni. Mole fraction A, kita pakai partial pressure A over the total pressure. And in this case, if you know already, you got how many gases inside it? So PA plus PB plus PC, which is the total pressure. Okay, so kalau nak jadikan PA sebagai what's it called, the subject, so akan guna mole fraction darab dengan total pressure dia. Nak cari partial pressure B, mole fraction times with the total pressure. Partial pressure C, you use the mole fraction C to times with the total pressure. But please remember, the maximum value for mole fraction is always 1. So maksudnya ketiga-tiga mole fraction XA, XB, XC semua campur sekali, dia tak boleh lebih daripada 1. 1.001 pun tak boleh. Okay. So is everyone clear? Is it okay for this one until this part? Okay, Dalton's law, yeah? So straight away into questions already. Panjang ni soalan. Takut. Jangan takut, awak sudah belajar ABC square ID kan. So beside Dalton's law, you can also mix with others law. Maybe you want to mix with boys, mix with Charles, mix with idea. It depends. Okay? Okay, so let's look at the question straight away. Alright, so question number 1. Yang gini. Sekejap Madam tunjuk. Okay, so just now in your notes notes yang Madam bagi, selepas sini ada application Dalton's law tapi Madam tak masuk dekat sini dulu. Madam guna contoh soalan dulu. So I will explain question 1 and 2 with you first before we go into the application. Okay. Are you clear? And then nanti Madam takut you lost. Madam, awak dekat mana sekarang ni? So Madam jangan sampai sini page yang ke-9. Question 1 and 2. Okay. So interpret the questions first. Based on the diagram below, the two tanks with two different gases are connected by a closed valve at the same temperature. So the valve is then released, okay, and both gases are allowed to mix. So you need to calculate the partial pressure for each gas, the total pressure, and the mole fraction. Okay. Sekarang ni Madam nak tanya, tank A kita ada oxygen gas. Dekat sini tank A. This is your tank A, oxygen gas. And it have 5 liter. Tank B, you have nitrogen gas. You have 3 liters over here. After you open the valve, maksudnya awak buka tengah-tengah sini, kita buka kan untuk bagi kedua-dua gas kita campur. Okay, so when I opening the valve, what is your total volume now? Total volume. Ada idea tak total volume?
8 liter.
8 liters, right? Okay. So, Madam nak lukis balik diagram If let's say for this kind of questions you can't understand, always refer to a simple diagram. So, let's say Madam lukis balik structure ni. Okay, ini 5 liter kita ada oxygen gas. Okay, and then 24 ATM. Ini ialah tank B. Kita ada 3 liter nitrogen gas and this one is happen at 32 ATM. So after it adding up together, so now I have a new volume. So the new volume over here is 8 liter. Okay, and then I have no idea what is the pressure inside it lah, because we will assume both of these gas they are not reacted. They doesn't react it. Okay, so in this case, laws apa yang kita apply untuk soalan yang pertama? Nak kirakan partial pressure each gas. I want to know the partial pressure of oxygen inside the 8 liter container. Okay, and the partial pressure for nitrogen inside the 8 liter container as well. So laws apa yang kita apply dekat sini? Anyone? Any suggestion? Apa yang tukar? Dia tak tahu, tak faham. Apa yang tukar dekat sini? Kalau kita fokus kat oxygen dulu. So now we focus on oxygens. Before this, oxygens 5 liter. So now the oxygens into 8 liters container. What is different?
Volume.
Volume is different. If volume become bigger, what happens to the pressure of oxygen?
Decrease.
Decrease, right? You got the Boyle's law. Okay, you got the Boyle's law. We're focusing on oxygens only. Okay, so 5 liter change to 8 liter. Bigger container. So for sure, the pressure for oxygen inside the new container will become smaller. Okay, so now we apply this one first. Madam, draw something for you. So let's say this is my V1. This one is my P1. So now I have got my V2 and this is my P2. P2 is what I want to find for oxygen. So let's just do some calculation. This is calculations for Roman 1, yeah? Your first questions. Okay, so for oxygen gas, we apply P1, V1, P2, V2. So put in your values. We start with pressure lah. Okay, so 24 atm, 5 liter. Second pressure is what we want to find for oxygen. And then the second volume, we have 8 liter. So what is P2? Let me know what is your value for the second pressure for oxygen. New pressure for oxygen.
15.
15. Everyone's agree?
Yes.
Jangan risau, ikut madam, cara madam ajar dekat sini. So sekarang awak tukar container, kecil kepada besar. Okay, bigger the volume, smaller the pressure. Okay, so now from 24 atm, it reduced into 15 atm. Okay, so let's just look at the nitrogen as well. Still the same, nitrogen from 3 liter, you change it into 8 liter. So 32 atm, when you change into the bigger volume, so for sure the pressure will reduce. So again, the same thing, change in volume, change in pressure, we apply Boyle's law. P1, V1, P2, V2. So apply your information. So this is your volume 1, pressure 1. So this is your P2. V2 is still the same, 88 liter. Because after opening the valve. Okay, so the second volume is the same for both oxygen and nitrogen. Okay, so we have 32, we have 3 liter. The pressure is what we want to find, and then we have 8 liter here. So what is your second pressure for nitrogen? Sorry? 12. 12 atm. So from 32 atm, it is reduced into 12 atm. Okay, sampai sini boleh ikut. Can you follow?
Yes.
We are trying to find the partial pressure of individual gas. Okay, individual gas inside the new container. So asingkan dulu. Nanti awak akan tengok soalan yang kedua dekat sini, dia tanya total pressure. So now, total pressure, we following which rules? So dekat sini Madam tulis Boy's law. Okay. So the second one, rules apa yang awak apply kalau awak ada dua gas yang berbeza dalam container yang sama? You want to find the total
Dalton's.
pressure. Okay, that is Dalton's law. Okay, so we have the formula. The Dalton's law, you must create the formulas, yeah? P total, okay, the total pressure, I use the symbol T to represent total, is the summations of the oxygen gas plus the partial pressure for nitrogen gas. Okay, and then inside a new container of 8 liter, here I have 15 atm for oxygen. I have 12 atm for nitrogen. So in total, I have 27. This is how we want to apply Dalton's law. Is it good? So Dalton's law dia memang akan combine dengan gas formula lain lah. Maksudnya awak nak combine dengan Avogadro's, Boyce, Charles ataupun ideal ataupun combine semua okey, tak ada masalah. Okay, but you need to know Dalton's law, you just want to find the total pressure. But before that, what formula you want to apply, then according to the questions. Okay. Is it good until this part? So yang ini ialah kita punya part 1 ya. Is everyone alright?
Yes, madam. Okay, madam.
Okay. Kita nak apply last one pula. Okay, part yang ketiga. More fractions of each gas. So, formula for more fraction? Formula? Oh, we do the formula first.
PO2 over
Yes, PO2 over the P total ataupun PO2 plus PN2. Pun boleh. So 15 over 27, which give you the values of 0. 0.56. Any unit?
tak ada.
Tak ada unit. Okay, more fraction
No.
tak ada unit. Okay, so untuk gas yang kedua, ada dua cara. Either you want to use PN2 over PT, or you want to use 1 minus 0.56 straight away. Sebab kita tahu maximum 1. So you only got 2 gas, so you can use this method. So it will give you the value of 0.44. Nak guna formula pun boleh lah, PN2 over PT. Okay, I'll give some time for you to jot down this one, yeah. So always use the diagrams to help you to recognize. Sebelum dia macam mana, selepas kita campur dia macam mana. So apa rules yang saya nak pakai? Is there any question under this part? Soalan pertama ada soalan. Soalan pertama, soalan. You able to get the answer? Semua jawapan dapat ya? Konsep okey tak?
Okay, madam.
Okay. So we got one more question, for the Dalton's law before the application. Application, madam think on the next lesson. Okay, let's just go to the second questions over here. Oh, ayat saja tak ada gambar. Okay, so second question over here, it says that a gas mixture containing 2.45 gram of nitrogen. So, mass of nitrogen. And also 3.10 gram of neon, mass of neon, occupy a volume of 2.5 liter. Determine the pressure of the gas at 25 degrees Celsius. Okay, so the pressure of the gas, it refers to what? What does it refer to?
Total.
Hmm? Total kan? Okay, so
Ya,
maksudnya
total.
dalam satu kotak 2.5 liter, inside I have nitrogen gas, I have neon. So what is the pressure of this one? They want to know about the total pressure. Okay, so formula yang apa yang kita boleh pakai untuk carikan partial pressure? Anything? What we can find? We want to find the total pressure, isn't it? So we must be able to find the partial pressure of each gas. So apa yang kita nak cari dulu? Nak pakai formula apa? Rules apa? Bukan rules, laws apa?
Ideal gas law.
Ideal gas law. Okay, tapi tak ada number of mole. Macam mana pula? Boleh?
Kita ada mass.
Yes, you have got the mass. So we find the number of mole of N2 first. 2.45 divided by 28. Molar mass of N2, 2 times 14, give you 28. So in this case, the number of mole of our nitrogen gas, 0.0875. Make sure you get the answer. Calculate. Kalau madam silap ke apa, awak boleh bagi tahu. So on another side, we do it for neon. So number of mole of neon, 3.10. Oh, madam forgot about what is it called? Atomic mass of neon. Anyone remember? Yuk, hilang. Kena cari juga, madam. Neon mass.
20.2.
20.2.
2.
Okay. So 20.2. Thank you very much. So 3.1 divided by 20.2, it gives 0.15. In this case, we take 35 lah. 1535. So if let's say number of mole nitrogen gas, you want to take 0.088 can. You want to take number of mole for neon 0.154 also can. All right. So we apply the PV and RT. Okay, so to make sure you get the partial pressure for nitrogen, number of mole of nitrogen, RT, over the volume. So insert lah awak punya substitute your value 0.0875, 0.08206. Temperature, don't forget to change it into Kelvin. And then the last one is your volume, 2.5. Similar to the partial pressure for neon, also you are applying PV and RT. So we use the number of molar for neon, okay, RT over V. Okay, so let me know about your answer over here. Untuk nitrogen dapat berapa? What do you get for partial pressure nitrogen? Tak ada orang. Wei. Hello.
0.856.
85,
0.56.
856, 8563 ATM. Can, no problem. 86 accepted. Okay, how about for neon? Neon, neon, neon. Do you have the neon?
1.5022.
1.5022. So we make both of your decimal point for nitrogen and neon the same. So easier for you to add up later. Okay, so now we want to apply your Dalton's law. Okay, so must write out the formulas. Yeah, P total equals to pressure for nitrogen plus the pressure for neon. Okay, normally in written exam, this formula it bear 1 marks. You will give 1 marks for the formulas written. Okay, so make sure everyone's write down the formula. After you have got the formula, you just add it up together. Okay, 1.5022, and then what is your total in ATM? And that's it. So add up together.
2.3585.
Very good. Well done. Tu nampak tak Dalton's law kita nak apply macam mana? Is it good?
Good.
Good. Okay. Madam, bolehlah. Okay. So, Madam nak try satu benda kita tinggal 10 minit lagi. And this is our end of topic. Untuk application Dalton's law will be on the next hour. Okay. Madam nak check whether I able to use this one or not lah. Okay. So, for the Padlet, I think you have used it before, isn't it? Pernah guna tak?
Pernah.
No.
Pernah.
Okay. So Madam nak try whether it's work or not lah. Madam first time use it. I paste it into the chat box over there. Okay. And then according to your class, dengar dulu awak ambil gambar apa yang awak buat hari ni. Whether it's Dalton's law or the exercises just now. I want to see just one pictures only. Okay. According to your class, take one pictures and then write your name. Okay, bila awak nak type message dekat situ ada kolom kan boleh type nama. Okay. And then you just post it. Madam want to see whether it's work or not.
Just choose which one, madam. Isn't it?
Anything. As long as what we discussed today. Nah, Dalton's law
Alright.
exercise tadi soalan pertama, kedua boleh. Ataupun yang tadi soalan 1 hingga soalan 8. Either one. Or just say your handwriting cantik ke tak. Upload. Ikut lorong ikut awak punya kelas. MS7, MS8, MS9, MS32. Don't forget to attach with your name. We just want to try whether it's work or not. Okay, well done. We got Aisha 1. Aisha, Soraya. Charlene, very good. Well done. Just post it. So according to your class, then Madam will see a few more work of your work to see whether you can follow or not. Okay, Hazi, Nazwa, well done. Keep on doing. Ashikin. You got Nuri. Cantik. Gemas. Okay, who else? Pei. We got AJ1. Okay, over MS9 I have Hannah. Well, very neat, yeah. Zitian. What else we have got? Akila Husna. Very good. Actually, just to make sure you write down the abbreviations are NH2, let's say. And the rest of you also the same lah. Okay. Got
Okay, madam.
Anis one. Shafika. Mawada. Ni siapa? Farah Tira. TJ. Fatin. Fatin also. Shazira. Shazira mana yang tak dapat nak ikut nanti boleh try buka balik OneNote ataupun YouTube Video memang Madam akan upload lah the latest by the night. Maksudnya hari ni kalau petang Madam sempat Madam akan terus upload. Okay, ada Balkis. Okay. Keep uploading semua orang kena upload. Nanti Madam tengok balik awak punya kerja. Yay. Okay, so Madam sharekan awak punya formatting assessment hari ni. Soalan pun senang. Hold on. Also inside the chat box here. So the question is very simple. The question is what we have discussed today. So which of the following laws applies the water displacement method? Sorry, Madam belum explain lagi. Tapi boleh refer nota water displacement method ikut laws yang last kali kita mention. Dah sempat untuk application. Okay, so the second and the third questions related to the conversions of unit. So practice a little bit. And then the last one is the gas constant R. But Madam change a little bit of the unit of volume. So choose it accordingly. So kalau awak memang ikutlah Madam punya kelas hari ni, awak akan dapat jawablah semua soalan dengan betul. Syariz ada. Bagus. Nurin. Maria. Well done. Nasha. Fifi. Shamimi. Atika. Okay, of course you can do your own notes. Beside Madam's note and the exercises we discussed, you may do your own notes also. Okay. So is there any questions before we